So this is section 4.6. We're going to talk about other trig functions, the graphs of them. Today in this video, I'm only going to cover tangent, cotangent. Tomorrow I'll cover cosecant and secant. So let's first start talking about the graph of tangent. Let's explore the equation of y equals tan x, just like we did for cosine and sine. I want you to think about what happens to tangent, and I'm going to begin with negative pi over 2, and I'm going to go up a rotation to, let's extend it to pi. So negative pi over 2, I'm also going to include 45-degree angles. Why? Because remember, on the unit circle, or if I'm drawing triangles and I'm evaluating tangent at 45 degrees, I'm going to get 1. Right? When I put square root of 2 over 2, square root of 2 over 2, I get 1 on the unit circle. Or if I'm evaluating the triangle, let me just create a quick triangle of 45 degrees. Remember, this is the angle that I'm looking at, opposite over adjacent, that's 1 over 1. So tangent at 45 degrees is 1. So I want to include that in my table of values. Okay? So now I'm going to include negative pi over 2, pi over 4, 0, pi over 4, pi over 2. And if we wanted to, just for the sake of what we're doing here, let's include an extra 90-degree rotation. Let's include 3 pi over 4 and pi. So we can see a pattern here. Actually, let's continue that so you can see the pattern. Let's include 7 pi over 4, not 5 pi over 4, I mean. 5 pi over 4 and 3 pi over 2. And see what happens. All right, a negative pi over 2, remember that's either a negative 90-degree rotation or a coterminal angle rotation of 270 degrees. The coordinate point on the unit circle corresponds to 0, negative 1. Tangent on the unit circle, remember you're putting y over x. So I'm putting 0, negative 1 is the coordinate point, so I'm putting negative 1 over 0. That gives me something that is undefined. At negative pi over 4, remember we said that it's going to be 1, right? And at negative pi over 4 specifically, the quadrant is x is positive, y is negative, so I'm going to get negative 1. At 0, the coordinate point on the unit circle corresponds to 0, 1. I'm saying that backwards. 1, 0. So I'm going to put 0 over 1. That's going to be 0. Pi over 4, I'm going to get 1. At pi over 2, again, I'm going to get undefined. At 3 pi over 4, I'm going to get negative 1. At pi, I'm going to get 0. At pi over 4, that's 5 pi over 4, I'm going to get 1 again. And at 3 pi over 2, I'm undefined again. So notice the pattern. The pattern is undefined, negative 1, 0, 1, undefined, negative 1, 0, 1, undefined. That pattern is going to be continuous. And what you start creating is a graph that looks like this. You start creating, remember, at points where you're undefined at, you're going to create these asymptotes. Negative 1, 0, 1, undefined. And then we're going to continue these graphs, and they're going to start looking like this and creating this pattern of negative 1, 0, 1, undefined, negative 1, 0, 1, undefined. So I'm going to have for tangent, and I'm going to create something that looks like this. So some characteristics that we need to know for the graph of y equals tan x is that the period, notice that it's cycling, it's starting to repeat undefined, negative 1, 0, 1, undefined in intervals of pi. It repeats. The domain, notice that we're excluding odd multiples of pi over 2. That's where those vertical asymptotes were happening at. The range is the set of all real numbers, and I can clearly see that because we're starting from negative infinity and increasing towards positive infinity on each interval. And you have vertical asymptotes at odd multiples of pi over 2. An x-intercept, this is really important, an x-intercept occurs halfway between those vertical asymptotes. So this is the midpoint of these two vertical lines. This is the midpoint of these two vertical lines, and this is the midpoint of these two vertical lines. Something else to note is what are quarter and 3/4 points. that happen at 1 and negative 1, right? Because that's what the pattern was, undefined, negative 1, 0, 1, undefined. So negative 1 and 1 are going to happen at 1/4 and 3/4 marks. I like to find these using midpoint formulas, and I'm going to show you what I mean in just a minute. Okay, so when you're graphing in the form of y equals a tan bx minus c, what I want you to think of this a, kind of like when we graphed y equals a sine of bx minus c, where a was the amplitude for sine and cosine, right? I want you to think of this the same way, except it's the point of inflection. That means that's the point at which you're going to start picking up or dipping down towards positive and negative infinity. I'll show you what I mean in just a minute. And bx minus c is going to help us to identify an interval at which we have that pattern, that undefined negative 1, 0, 1 undefined pattern occurring at. Well, how do we find that? What you have to do is first start by finding two consecutive asymptotes. And how do we find those two consecutive asymptotes? We're going to use this formula. We know, based on what we just evaluated, that tangent has asymptotes occurring at odd intervals of pi over 2. Well, if that's true, then I'm going to create these boundaries and solve for my new asymptotes for any transformations. And I'm going to find them. I'm going to get my positive and my negative, or it could be two positive ones depending on how big that shift is for your two new asymptotes. Then you're going to find the midpoint between those two things, and that's your x-intercept. And then you're going to find your 1/4 and 3/4 marks for that negative 1 and that positive 1 inflection point. And then continue graphing full periods as needed. So less simple, so that way you can see what I'm talking about. Okay, so the first thing you want to note is, note that this negative symbol here is going to reflect tangent over the x-axis, right? So that means when it curves like this, it's no longer curving like that. It's going to curve in the opposite direction because you flipped it over the x-axis. There is no value in front of tangent. That means that the inflection point is going to happen at 1. Think what we learned about asymptotes for sine and cosine. And now what we're going to do is we're going to take everything that's happening to the right of tangent, and we're going to put it in that inequality statement. Negative pi over 2 less than 2x less than pi over 2. So the first thing I'm asking you to do is to find the asymptotes. So I'm just going to abbreviate this. So you're going to find the asymptotes. Now we're going to want to solve for x, so I'm going to divide both sides by 2. Here on the left, we're going to get negative pi over 4 less than x less than pi over 4. What we just identified are our new asymptotes. They're no longer occurring at negative pi over 2 or pi over 2. They're occurring at negative pi over 4 and pi over 4. The next thing I want to do, the second thing I want to do, is I want to find the midpoint of those two asymptotes. So midpoint is our x-intercept. So I'm going to take negative pi over 4, add pi over 4, and divide that in half. What do I get?
0.
0. Okay, I'm going to just start graphing what I have here so I can point something out. Alright, so this is so far what we've identified. At negative pi over 4, we have a vertical asymptote. At pi over 4, we have another vertical asymptote. In between that, I have my x-intercept, and it's happening at 0. Remember your tangent curve, the pattern is undefined, negative 1, 0, 1, undefined. So it's going to create this pattern here. But remember, we reflected it over, so this one's actually going to go in this direction. So now I need to find the point at which that's halfway between this vertical asymptote and this midpoint. I want to find the midpoint between negative pi over 4 and 0. That's going to be my first quarter point. So what I'm asking you to do is find this quarter point and this quarter point. So I'm going to find that quarter point, again, by taking this x coordinate and this x coordinate, adding them, dividing by 2. The third thing we want to do is find the first quarter point. Let's call it quarter point. You're going to take your left vertical asymptote, and you're going to take your midpoint, and you're going to divide it in half. So that's negative pi over 4 divided by 2 is negative pi over 8. And then to find your 3/4 point, your third quarter point, you're going to take your midpoint and your vertical asymptote to the right, which was pi over 4, divide that in half, and you're going to get pi over 8. All right, so we identified our first quarter point. We said that that was negative pi over 8. And we identified our 3/4 point. We said that that was pi over 8. Remember, we reflected this particular graph over the x-axis, so instead of starting low, it starts at 1. And instead of going back up, it's going to go down in this direction. So this would be one interval for that particular transformation. And if I wanted to, I can add an interval to the right. Let's determine how we're increasing. We're increasing in intervals of pi over 8. That's the pattern that we just identified. 0 pi over 8. This is 2 pi over 8. My next one is going to be 3 pi over 8. 4 pi over 8. 5 pi, you can reduce these if you want to. 5 pi over 8. Just want to show you that this is the pattern. And this is 6 pi over 8. Here I must have a vertical asymptote that reduces to an interval of pi over 4. And in the middle, in the midpoint, I have an intercept, my first quarter point, my 3/4 point, and then it creates another tangent curve. All right, here's another example. Okay, so we want to graph the equation y equals the tangent of x minus pi over 2. So the first thing I want to do, remember, is you want to find those asymptotes. That's the first step. Find, I'm going to call it, I'm going to abbreviate. Again. So I want to find my asymptote. So what the parent graph, one interval happens between negative pi over 2 to pi over 2. So I'm going to take this transformation and put everything I see to the right of tangent in between this inequality. So that's going to be x minus pi over 2. And then I'm going to solve for x. In order to solve for x, I have to add pi over 2 on both sides of the inequality along with the middle. And then I can simplify this. Negative pi over 2 plus pi over 2 is 0. X is finally by itself. Pi over 2 plus pi over 2 is 2 pi over 2, or pi. This is, again, where your new asymptotes are occurring at. They're occurring at 0 and pi. The next thing you want to do is you want to find the midpoint. Find the midpoint of those asymptotes. Why? Because that's going to be the only x-intercept that interval has. So I'm going to do 0 plus pi divided by 2. That's going to be pi over 2. The next thing I want to do is I want to find my 3/4 and 1/4 mark of that interval. So in order to find the first quarter, I'm going to take the left asymptote, which is 0. I'm going to take the midpoint, which is pi over 2, and I'm going to find the midpoint here. That's pi over 4. That's the first quarter point. Then in order to find the third quarter point, I'm going to take my midpoint, which is pi over 2, my rightmost asymptote, which was pi, and I'm going to divide that in half. Remember, pi is 2 pi over 2, so 2 pi over 2 plus pi over 2 is 3 pi over 2. Divide that in half is 3 pi over 4. So this is your 1/4 mark, this is your third quarter mark, and that's where your point of inflection is. Remember that 1 and that -1 point? That's where that's occurring at. So let's put this on the graph and see what that looks like. So this is what our coordinate plane looks like so far. Remember, we identified at 0 we have a vertical asymptote. At pi we have a vertical asymptote. Our midpoint is occurring at pi over 2. And our point of inflection is, remember, the tangent graph goes in this direction. So it starts low at -1. And then it goes up to 1. And this would be 1 period of the tangent graph. We can extend this by graphing another full period, either to the right or to the left. Because this one begins at 0, it's going to be really easy to duplicate what we did on the right on the left. So if I were doing this problem on a test and I wanted 2 full cycles, I would just go to the left at negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. And then here you know you should have another vertical asymptote. You're going to have a point of inflection here, a midpoint, point that peaks, and it goes like this. So that would be 2 cycles of your tangent curve. Alright, so let's explore the graph of cotangent. The graph of cotangent is the reciprocal, remember, the reciprocal of tangent. So let's actually evaluate a quick table of values for y equals cotangent of x around the unit circle so we could see what's happening. Here I'm going to pick values starting at 0. I'm also going to include pi over 4 because remember cotangent is also going to, anything divided by itself is 1. Or think back to that triangle I just drew. Cotangent is going to be adjacent over opposite, and you're still going to get 1 when you evaluate anything in the interval of pi over 4. Let's take a look at what happens at pi over 2, at 3 pi over 4, and at pi. At 0, the coordinate point is 1, 0. Here you put x over y on the unit circle. So it's actually going to get undefined here, because this time you're putting 1 over 0. At pi over 4, we said we get 1. At pi over 2, here this is going to be 0, 1. Or, remember, x over y. 0 over 1 is going to give us 0. At 3 pi over 4, we're going to get negative 1. At pi, we're going to get undefined again, because you're going to have the coordinate point negative 1, 0 on the coordinate plane, and you're going to put negative 1 over 0, and you're going to get undefined because you can't have 0 in the denominator. So now I can see that reversal here. Notice that the period this time is happening from 0 to pi. You still have your midpoint, you still have these points of inflections, you still have that repetitive cycle, undefined, 1, 0, negative 1, undefined, so that's reversed. And some characteristics to note are as follows. The period is pi, just like tangent. The domain's all real numbers except integral multiples of pi. So that was pi over 2 for tangent. So that's the only difference here so far. The range is a set of all real numbers. You're going to have vertical asymptotes at integral multiples of pi. You still have x-intercepts that occur at midpoints, and it's an odd function, just like y equals x cubed with origin symmetry. And you're going to have those quarter and 3/4 marks, and you find them the same way. Let's take a look at an example so you can see how to do a problem that looks like this.
Would this be the same thing as like flipping?
So something to keep in mind, here are some steps that we want to take when we're solving for the graph of y equals a cotangent bx minus c. Again, this is going to be, think of your amplitude, that's going to be that point of inflection. Bx minus c is going to help us to identify our new asymptotes. That's exactly what we want to do first. We want to find those 2 consecutive asymptotes. But instead of having the boundaries of negative pi over 2 and pi over 2, we're going to have 0 and pi. Then we're going to find the midpoint between those 2 new asymptotes, and then we're going to find the quarter and 3/4 marks just like we did before, and then we're going to use that to graph more cycles. I could either go to the right or to the left. Here's our first example, example number 3. It says graph the following equation, y equals negative cotangent pi over 2. Alright, so this negative in front of cotangent is going to reflect the graph over the x-axis. So now the curve is going to look like the tangent curve. So it's no longer going in a direction that looks like this. It's now going to go in the tangent direction. So keep that in mind. The value 1 is going to create our point of inflection, the highest point up and down before it starts peaking towards positive infinity and dipping towards negative infinity. So again, the first thing you want to do, just like when you were graphing tangent, is find your new asymptotes. So first start by finding the new asymptotes. So I'm going to, everything to the right of cotangent is going to be set in the interval between 0 and pi. How do I get x by itself? Divide by pi over 2. Think of an algebraic inequality. 0 divided by pi over 2 is 0. Pi over 2 divided by pi over 2 is 1. And pi divided by pi over 2, that helps you put pi over 1, do state change, flip, and now you can clearly see that you end up with 2. So the new vertical asymptotes are occurring at 0 and 2. The next thing you want to do, just like when we were graphing tan, Second thing is find the x-intercept. How did we find that? We found the midpoint between the two vertical asymptotes that we just finished finding. So I'm going to do 0 plus 2 divided by 2, I get 1. That's my midpoint. That's my only x-intercept for the graph of cotangent. The third thing I want to do is find my quarter and 3/4 marks. Again, you take your leftmost vertical asymptote, which is 0, your midpoint, which we just found, which was 1. You divide that in half because you're finding the midpoint, and that value for the first quarter point is a half. Your third quarter mark, take your midpoint, which was 1, take your rightmost vertical asymptote for this one cycle, add those, divide by 2, we get 3 halves. And now we can graph one cycle of cotangent. So this is what the coordinate plane is looking like before we start graphing. Remember, we have a vertical asymptote happening at 0, at 2. We have a midpoint, the only x-intercept here at 1. Remember, this graph was reflected over the x-axis, so that means that we're going to start at the low point of inflection, then we're going to pick up at the high point of inflection. So this would be one cycle of cotangent. And then if we want to graph an additional cycle, it will be easy to duplicate everything we just did here to the left. I could do -1/2, -1, 3/2, 2. Or if I wanted to, I can add in the direction towards the right. But like I said, if I'm at the origin, I might as well go to the left. It's easier. And then you can see here, stop it. This would be an additional cycle of cotangent. All right, let's do one more example and then we'll wrap up this video. Again, where you want to begin graphing this is you want to find those new asymptotes. So you're going to set everything that's to the right of cotangent in this interval between 0 and pi. Here we have to add pi to the right and to the left. And our new vertical asymptotes are going to happen at pi and 2 pi. Notice that if I graph one cycle to the left, that's going to be 0 to pi. So really no change. This is the parent, just one cycle to the right. And if it's indefinite, it's going to be the same as one cycle to the left. So the midpoint is what I want to find next. Remember, this is my x-intercept in the interval from pi to 2 pi. So I'm going to do pi plus 2 pi, divide that in half, I get 3 pi over 2. The third thing I want to do is find my quarter point and my 3/4 point. So in order to find my first quarter, I take my left asymptote, I take my midpoint, I divide that in half. This is equivalent to 2 pi over 2. 2 plus 3 is 5 pi over 2. 5 pi over 2 divided by 2 is 5 pi over 4. Then in order to find the third quarter, you're going to take your midpoint, which was 3 pi over 2, and your rightmost vertical asymptote. If you want, write this with a common denominator, 4 pi over 2. So that's going to be 7 pi over 2. Divide that in half, and you're going to get 7 pi over 4. And now we're going to go ahead and graph that. All right, so this is what our coordinate plane is looking like. Remember, at pi and at 2 pi, we have these vertical asymptotes. At 3 pi over 2, we have our midpoint. Our point of inflections, we're at 5 pi over 4 and 7 pi over 4, and cotangent goes in this direction. If I want another cycle, what I was saying was I can graph easily to the left because I know this is a distance of pi. This is a distance of pi. Therefore, I have another vertical asymptote here. Halfway between 0 and pi over 2 is pi over 2. This would be pi over 4. I would repeat the cycle like this.